Okay, so in solving this problem, everybody's attention. I don't like the wording of this problem. I don't have everyone's attention here. What I'm going to do and what I should, well, maybe I won't do it in time or maybe I won't remember, but if you look here, it says the problem says find the net torque produced by the forces F1 and F2 about the rotation axis shown in the drawing. But it also says that the forces are acting on a uniform rod of mass 5 kilograms. What I need to do to correct this is I probably should say find the net torque produced by the forces F1 and F2 and the weight of the rod, so that you know that I want the net torque that includes all the forces that are acting on this. And the weight of the rod, since it's a uniform rod, I know it's going to be located at its geometric center. So it's going to be right there. That's going to be where the weight is located, right in the middle. And 5 times 9.8, because all of these are newtons, so I want the weight, I don't want the mass. That's going to end up equaling, the weight is going to equal 49 newtons. Because 5 times 9.8 is 49 newtons. So now that's my completed free body diagram, because it has all the forces that are causing this thing to rotate. Now, the pivot point in this problem is given as right there. If my pivot point was here, the torque is going to be a different value than if it's there. My torque is going to be a different value if it's there. It's going to be a different value if it's there. If I were doing this and I were trying to, let's say, figure out the force that's needed so that this thing doesn't move at all, I would probably make that my pivot point, because it would eliminate the only force on this rod that's not perpendicular to the rod. So if I put it right there, I don't even have to consider this thing. But there's the pivot point. So the first thing we want to do to get the first 10 points is to figure out the torque that's on this rod. And so I'm going to have the torque equals, first we have this one. It's an up force and it's to the left of the pivot point. So it's making it go that way. That's what? Clockwise, and clockwise is plus or minus? Minus. So it's going to be minus 27 newtons times 0.9 meters, because that's how far it is from the pivot point. And then look at the weight. The weight is a down force to the left of to the right of the pivot point, and it's also making it go what? Clockwise. So it's also going to be minus 49 newtons times its distance to the pivot point. So who can tell me what is its distance to the pivot point? The whole thing, 0.85, yes. 0.85, good. It is 0.85. And you get 0.85 because from here to there is 3.5. So from there to there is 3.5. Well, half of 3.5 is 1.75. So I know that from there to there is 1.75. Well, if that's 0.9, then to get to 1.75, that has to be 0.85. So that's where that number comes from. Now this, remember, that's from there all the way to there. It's not from here to there. It's from there all the way to there. So the final force, I need to take this force that's on there and break it into its perpendicular component. So that's the arrow. This is the force that I need, not that. I need this. Well, I could take this and put it on the end there. So if I want to think of this as my triangle, then this side is the opposite side from that triangle. So first of all, is this making it go clockwise or counterclockwise? Counterclockwise, so this is the only one on here that is plus. And it's going to be 34 newtons, because that's the full vector, and times either the sine or the cosine, depending on what side is my perpendicular component. What will I use? Sine. So it's going to be the sine of 41 degrees times the distance, which is 2.6 meters. Now, notice I went right to putting in numbers. Like I didn't put, I mean, you could write this as F1, like I could put F1 times, I don't know, call that L1, and then I could call that W, and I could call that F2 and that L2. But when you're doing these problems, I mean, you're not really doing much algebra. You're just adding them all up. So it's fine with you going directly to plugging in the numbers. So, and those that mess up on this, on these types of problems, they mess up on the L's. Like they don't get these right. If you get these right, you're going to get the answer right. And the answer for this problem, I gave it to you, right? It was, oh, I didn't then change it to the right answer?
No, you didn't put in the way.
Oh. Okay, so the correct answer is negative 7.95 Newton meters. All right, any questions with that? And I still have time, then I'm going to now go, so that would be worth 10 points for getting the torque. Now the next question would be getting the I. Now to get the I, we have to treat this as it is a rod, but our formula only works when the pivot point is through one end of the rod. So we're going to make this a rod with the pivot point through one end, and then this as a rod where the pivot point is through one end. That way we can use the formula that we have. But the thing is, I know that the mass of the whole thing is 5 kilograms, so the next thing I need to do is figure out how much of that 5 kilograms is to the left of the pivot point and how much of that mass is to the right of the pivot point. So we have to do that. So the next thing is I'm going to figure out the mass to the left of the pivot points. And that's going to equal the full mass, 5 kilograms, times the fraction to the left of the pivot point. And what would that fraction be? What would that fraction be? It would be one. No, it would. If that was 1.8, it would be 1/3. Exactly. Yes, it's going to be 0.9. I'll put the meters. You don't have to. Over 3.5 meters, because all I'm really doing here is getting the fraction of the 5 kilograms. So I have 0.9, which is this, divided by the whole thing. That gets me the fraction. So that's going to equal, what does that equal? 1.29 kilograms. So I should get, for the other one, 3.71, because that's what's going to add up to 5. But let's do it the long way so we can check and see if they do add up to 5. So the mass to the right is going to be 5 kilograms times 2.6 meters over 3.5 meters, because that's the other half, that's the other side to the right of the pivot point. So from here to there is 2.6 divided by 3.5, the whole thing. And that, I hope, comes out to be 3.71. And now that we have that, we can just plug it into the formula for, we can plug it into the formula for I. I'll do it in a different color here. So I, our basic formula, I'll just put it down just so you know, is 1/3 ml squared. We got two 1/3 ml squareds, the part to the left and the part to the right. So I'm going to have 1/3 ml squared plus 1/3 ml squared. And our two masses, I need to bring this down a little bit so I can see them. We have 1.29 kilograms. And we have 3.71 kilograms. And this length on the left is 0.9 meters. And to the right of it, it's 2.6 meters. So if you solve that, you get, now the way I would put this in my calculator is I would go 1.2 times 0.9 squared divided by 3 plus 3.71 times 2.6 squared divided by 3. And if you do that, the answer should have come out to be, I hope, 8.71 kilogram meters squared. And that, what I just did there, that is 10 points. What I did in blue, that's 10 points. And the only thing left to solve for now is the angular acceleration, which is alpha. So the formula we're going to be using is torque equals I alpha. That is the formula that I just put here. That's Newton's second law for rotation, because F equals ma corresponds to torque equals I alpha. And we have the I and we have the torque. And guess what? To get these 10 points, real simple. All you have to do is show me a torque divided by an I. And even if you got these two answers wrong, as long as you give me the answer for part A and divide it by your answer for part B, you'll get the 10 points for part C, because I would have already taken off the points in A and B. So you're going to get negative 7.95 Newton meters. And the negative there actually is important, because the direction of the torque is the same as the direction for the angular acceleration. It's not like when I use the formula with torque and force, because a negative for force is down, a negative for torque is clockwise. But in this one, that negative means clockwise, so I am going to get a clockwise angular acceleration. Whoops, what am I doing? And solving that, your answer is going to be in what units? Radians per second squared. So negative 0.913 radians per second squared.